welcome students, this course on data analytics with Python. Today is the introduction class. This lecture is on introduction to data analytics. The objective of this course is to introduce the conceptual understanding using simple and practical examples rather than repetitive and point click mentality. Here most of the students generally how they are using the software for doing data analytics, just they want to just click it, they want to get the result, they do not bother about exactly what is happening inside the software. This course should make you comfortable using analytics in your career and your life. You will know how to work with the real data, and you might have learned many different methodologies, but choosing the right methodology is important. This course will help you how to choose the right data analytics tools. When you look at this picture, how this person is using this tool, there is a ladder. He was not knowing correctly how to use this ladder for the purpose it is intended. So, the danger in using quantitative method does not generally lie in the inability to perform the calculation. Because of the computer development in computer technology, there are many packages are available for doing data analytics, but the real threat is lack of fundamental understanding of why to use particular technique or procedures and how to use it correctly and how to correctly interpret the result. This course will focus on how to choose the right technique and how to use it correctly and how to interpret the result. So, what was the learning objective of this class? That is, after completing this lecture, what you will learn? One is you can define what is data and its importance, you can define what is data analytics and types, you can explain why analytics is in today's business environment is so important. Then we can see how statistics, analytics and data science are interrelated. There seems to be some overlap in this. We will clarify that what is the difference, how these are overlapped, how these are interrelated. Then in this course we are going to use a package called Python. I will explain why it is important to use Python in this course. At the end of this session, we will explain the 4 important levels of data, that is nominal, ordinal, interval and ratio. Now we will go to the content. We will define data and importance. There are 3 terms, one is variable, measurement and data. Next we will see what is generating so much data. Next we will see how data add value to the business. Then we will say why data is important. See, the variables, measurement, data, these are the terms which we are going to use frequently in this course. So, what is a variable? Variable is a characteristics of any entity being studied that is capable of taking on different values. Say for example, x is the variable. It can take any values, it may be 1, it may be 2 or it may be 0 and so on. The measurement is when a standard process is used to assign numbers to a particular attributes or characteristics of variable is called a measurement. For that x, you want to substitute some values. For that values you have to measure the characteristics of the variable, that is nothing but your measurement. So, then what is the data? Data are recorded measurement. So, there is a variable, you measure the phenomena, after measuring that phenomena you are substituting some value for the variable. So, that the variable will take a particular value, that value is nothing but your data. So, x is the variable, for example number 5 is the data. How you are measuring that 5? That is called measurement. Then what is generating so much of data? Data can be generated different way, humans, machines, human machines combines, the human machine combines in the sense now see everybody is having the various Facebook account, we have LinkedIn account, we are involved in various social network sites. Now the availability of the data is not the problem. Okay. It can be generated anywhere where the information is generated and stored and structured or unstructured format. So, how the data add value to the business? So, the data after getting from various sources, assume that it is stored in the form of data warehouse. So, from the data warehouse, the data can be used for development of a data product, Here we are using the word data product. In the coming slides I will explain exactly what is the data product, some examples. So, the same data, if you look at the right hand side, that can be used to get more insights from the data. Okay. What do you mean by the data product? For example, algorithm solutions in production, marketing and sales, example of some data product. For example, recommendation engine, one of the example for data product. Suppose if you go for Flipkart or Amazon, if you are buying a particular product, that package, that software itself will recommend you what is the next product, possible product that you can buy. That is nothing but the recommendation engine. Even if you watch some YouTube videos on a particular topic, that YouTube itself will suggest to you what are the relevant videos are available. So, that is a recommendation engine. That is one of the example of your data product. With the help of data, so that will help you to form a data product, or you can get a insight from the data that will add a business value to you. See, this is an example of your data products. This is the driverless car, Google car. So, the whole concept of Google car is, with the help of data, it is detecting all other requirements for driving the cars. The next example is for recommendation engine. As I told you previously, when you buy any product, they will suggest you that along with this product, the other product also can be purchased. Another very common example for a data product is Google. The Google is a lot of applications there. One of the application of example for data product is Google mapping. So, the Google mapping is helping you to find out what is the right route, which route there is a traffic, in which route there is a toll booth. So, this kind of informations we can get it from the Google map. So, this Google map is the one of example of your data production. Now, why data is important? The data helps in making better decisions. Data helps in solve problem by finding the reason for underperformance. Suppose some company it is not performing properly, by collecting the data we can identify what was the reason for this underperformance. The data helps one to evaluate the performance. So, what is the current performance? The data also can be used for benchmarking the performance of your business organization, and after benchmarking, data helps one improving the performance also. So, data also can help to understand the consumers in the markets, especially in the marketing context. You can understand who are the right consumers and what kind of preferences they are having in the market. Next, we will define what is a data analytics and its types. So, in this coming 2-3 slides we are going to discuss, we will define what is data analytics, then we say why analytics is important, then we will see the data analysis, then we will see how data analytics is different from data analysis. At the end we will see types of data analytics. We will define data analytics is the scientific process of transforming data into insights for making better decisions. See, it is a scientific process for transforming the data into for making better decisions. Even without data also, even without doing analytics also you can make the decision, but you cannot make the better decision without analytics. By the virtue of your experience and intuitions, you can take the decisions that also sometimes may be correct, but with the help of data, if you are making the decision, then that will enable you to make the better decisions. Another professor, James Evans, he has defined the data analytics in this way. It is the use of the data, information technology, statistical analysis, quantitative methods and mathematical or computer based models to help managers gain improved insight about their business operations and make better fact based decisions. You see that there are many terms which are appearing here. One is IT, next one is a statistical analysis, next one is a quantitative methods, then mathematical knowledge and computer based models. So, when we will see how these are interrelated in coming slides. Generally among the students there is a confusion whether the analysis and analytics is same or different. Why analytics is important? The opportunity abounds for the use of analytics and big data such as for determining the credit risk, for developing new medicines, especially in healthcare. The healthcare analytics is emerging, that is helping you to identify what is the correct medicines. Finding more efficient ways to deliver product and services, and for example, in the banking context, data analytics is used for preventing the fraud, and it is uncovering the cyber threats. With the help of data analytics, you can find out the possible cyber crimes, and we can detect it, we can prevent it. And data analytics also important for retaining the most valuable customers. We can identify who is your valuable customer or non-valuable customers. So, we can focus on more on our valuable customers. Okay. Now, what is the data analysis? Is the process of examining, transforming and arranging raw data in a specific way to generate useful information from it. So, data analysis allows for the evaluation of data through analytical and logical reasoning to lead to some sort of outcome or conclusion in some context. Data analysis is a multifaceted process that involves a number of steps, approaches and diverse techniques that we will see in coming lecture. So, now we will see what is the analysis is, data analysis and data analytics. When you say analysis is, when you say data analysis, it is something about what has happened in the past. So, we will explain why that has happened, we will explain how it has happened, we can explain why it has happened. For example, when we say data analysis, that is nothing but studying about what has happened. It is like kind of a postmortem analysis, what has happened in the past. Okay. In the contrary, the analytics is studying about what will happen in future, and with the help of analytics we can predict, explore possible potential future events. So, the analytics is maybe qualitative or quantitative. For example, in analytics, if we say qualitative analytics, so it is the decision mostly based on the intuition, but when you say in quantitative, where with the help of formulas, with the help of algorithms, we will make the decisions. So, in the analysis, data analysis also we can go for qualitative, we can explain how and why a story ends in that way it did. When we say in quantitative, we can say how the sales decreased the last summer. Say when I say, as we are repeating, when you say analysis is something studying about what has happened in the past. Okay. So, it is not exactly analysis equal to analytics. Similarly, when you say data analysis is different, data analytics is different, similarly business analysis is different, business analytics. When I say analytics is nothing but studying about the future events with the help of the past data. Next we will go for classification of data analytics. Based on the phase of workflow and kind of analysis required, there are 4 major types of data analytics. One is descriptive analytics, diagnostic analytics, predictive analytics and prescriptive analytics. We will see these 4 types of analytics in detail in coming classes. If I look at the difficulty and the kind of value which we can get from different types of analytics, this picture shows, for example, when you see the descriptive analytics, that will answer what happened. Diagnostic analytics will help you to answer why did it happen. Predictive analytics will help you what will happen. Prescriptive analytics will help you to answer how can we make it happen. That is one context. When you look at the level of difficulty, you see that the descriptive analytics level of difficulty is very less. On the contrary, when you look at the prescriptive analytics, the difficulty level is more and the value also, value in the sense business value which adds to you also more. So, when there is a more difficulty, there is a more value. Okay. Then we will say what is the descriptive analytics. Descriptive analytics is the conventional form of business intelligence or data analysis. It seeks to provide a depiction or summary view of facts and figures in an understandable format. This either inform or prepare data for further analysis. So, descriptive analysis, or we can say another way in statistics, can summarize raw data and convert it into a form that can be easily understood by humans. They can describe in detail about an event that has occurred in the past. Okay. Some of the examples of descriptive analytics is, a common example of descriptive analytics are company reports that simply provide the historic review like data queries, reports, data descriptive statistics, data visualization and data dashboard. Okay. The next one we will go to the diagnostic analytics. Diagnostic analytics is a form of advanced analytics which examines data or content to answer the question why did it happen. So, we are diagnosing, suppose we are meeting a doctor for consulting. So, he will try to understand why this has happened. Okay. So, that kind of analytics is nothing but diagnostic analytics. So, the diagnostic analytical tools aid an analyst to dig deeper into an issue so that they can arrive at the source of the problem. So, the doctor also will identify if somebody has got some disease, what was the sources of the problem. Similarly, the diagnostic analytics also, if something has happened, for example, the company is not performing well, that diagnostic analytics will help you to identify what was the core reason for that. In a structured business environment, tools for both descriptive and diagnostic analytics go parallel. So, when you look at the whether it is a prescriptive or diagnostic analytics, the tools, analytical tools which you are using can be same, only the purpose may be different. For example, data discovery, data mining, correlations, these tools can be used for your prescriptive analytics also. Okay. Now, we will go for predictive analytics. Predictive analytics helps to forecast trends based on the current events. When you say predicting, obviously it says that it is discussing about what will happen in future. Predicting the probability of an event happening in future or estimating accurate time it will happen can all be determined with the help of predictive analytical models. Many different but codependent variables are analyzed to predict a trend in this type of analysis. So, in the predictive analytics, one of the tool is the regression analysis. There may be some independent variables, some dependent variables, sometimes more dependent variable, more than one dependent variable, and how these variables are interrelated. So, that kind of study is nothing but your predictive analytics. When you look at this picture, you see that with the help of historical data, by using different algorithm, predictive algorithms, you can come with a model. Once the model is developed, a new data can be fit into this model. So, we can get some predictions about the past events. Okay. Example is linear regression, time series analysis and forecasting, data mining. These are the techniques for predictive analytics. The last one is a prescriptive analytics, a set of techniques to indicate the best course of action. It tells what decision to make to optimize the outcome. The goal of prescriptive analytics is to enable quality improvements, service enhancements, cost reductions and increasing productivity. Okay. In the prescriptive analytics, some of the tools which we can use is optimization models, simulation model, decision analysis. These are the tools under prescriptive analytics. Next is we are going to see why the analytics so important. In this section we will see what is happening, the demand for data analytics, and we will look at the different elements of data analytics. This picture shows Google trends. This was up to 2017. See, for example, the blue represents the data scientist, this orange represents the statistician, operation researchers. You see the trend is it is increasing. That means people are searching in the Google search engine the word data scientist more number of times. See the search count is it is increasing. That means there is a demand for that particular say job. you see, if you look at this, this is the newspaper clipping from Times of India. There are so many news are coming about data scientists and the future requirement of data scientists. You see the data scientists earning more than CAs and engineers. You can look at this link for further. And you see the demand for data analytics. This is also newspaper clipping, with companies across industries striving to bring their search and analysis department up to speed. Demand for qualified data scientists is rising. So, there is an emerging field. So, many companies is looking for the qualified data scientist. So, if you take this course, at the end of the course, that you may be qualified for getting into these companies. Many times you see what is data analytics, statistics, data mining, optimizations, these are students having different understanding on that. So, when we say data analytics, there are different elements. One is statistics, next one is the business intelligence information systems, then modeling and optimizations, then simulation and risk. We can say if you are able to do what if analysis, that is nothing but sensitivity analysis, visualization, data mining. These are the components of data analytics and how these different domains are interrelated. Next we will see what kind of skill set is required to become a data analyst. Then we will see the small difference between data analyst and data scientist. See, to become a data analyst is the basic fundamental knowledge is you need to have knowledge of mathematics. Next you need to have the knowledge of technology, is nothing but hacking skill. Hacking skill in the sense, if the data is given, hacking is done in the looked at the positive way, how to use the data to get more informations. The next skill is business and strategy acumen. You should have the knowledge of the domain, knowledge of the business, and you need to have the strategy acumen. So, these three skills are required for a good data scientist. It is very difficult to have one person will have all these three skills. That is why availability of good data analytics is becoming very difficult, because somebody may be very good at mathematics, but they may not have very good knowledge in business. Some people may have very good at technology, they may not, technology in the sense information technology, they may not have good knowledge on the business knowledge or and so on. So, we need to have the combination of all these three skills, otherwise the group of people, some people from mathematics department, mathematics area, some people from computer science, some people from the domain knowledge, they have to work together to form a good data scientist team. So, this forms data science. Now, what is the difference between data analyst and data scientist? And the difference is what kind of role they are doing. For example, the role of a data analyst is, see, in a business context, he may have the knowledge of business domain. For example, if he is good at doing analytics in the area of marketing, he can be called as a marketing analyst. If the person is from finance area, he can be called it as a finance analyst. So, he is the analyst, data analyst. But the role of data scientist is little bigger, because the data scientist need to have the knowledge of advanced algorithms and machine learning and able to come out with a data product, which I told you in the previously. So, the data scientist can come out with a data product. Okay. In this course we are going to use Python. In the next lecture I will tell you the basic introduction about the Python. Here we will see why we are going to use the Python, because Python is very simple and easy to learn. Most importantly, it is a freeware and open source. It uses interpreted, it is not the compiler. Suppose what you mean by compiler and interpreter is, you need a compiler to solve the whole program, but interpreter need not be in that way. It can solve, even you can interpret one sentence also, one line in the programming line also. It is dynamically typed. Dynamically typed in the sense in some other programs every time you have to declare the variable, what is the nature of the variable, whether it is integer, whether it is a float, but here you need not do, it is dynamically it takes the value. It is extensible, extendable sense if you make a code in some other language that can be extended with the help of Python, and can be embedded, embedded in the sense you have made some program in Python, it can be embedded with some other platforms, and it has extensive library. The usability of Python is it is a desktop and web applications, it can be used for data applications, it can be used for networking applications, most importantly it can be used for data analyst, data science, can be used for machine learning, it can be used for IoT, Internet of Things and artificial intelligence applications, and can be used for games. The another reason for choosing Python is most of the companies they use Python as a language in their company, like for example Google, Facebook, NASA, Yahoo and so eBay, they use Python as a programming language. In this Python also we are going to use a Jupyter notebook, in the next class I will explain you, because it is the client server application, is edit code on web browser, easy in documentation, easy in demonstration and user friendly interface. This was the last session of this lecture. We will explain 4 different level of the data. One is the type of variables, level of data of measurement, compare 4 different level of data, we will say nominal, ordinal, interval and ratio. Will we see that what is the usage of knowing this different level of data. The one way for classifying the data is the categorical data, one is the numerical data. In categorical data, you see marital status, political party, eye color, these are categorical data. Numerical data, it can be discrete or continuous. Discrete data may be a number of children, defects per hour, so it is the discrete data. In the continuous data may be weight, voltage, these are the example of continuous data. So, what is the difference between discrete and continuous is, you say a number of children, you may say 2 children or 3 children, 2.5 children is not possible. But in continuous, if you look at between 0 and 1, the numbers are continuous, there is infinite number of values are there between 0 and 1. So, it is a continuous variable. Next we will see the different level of data measurement. Previously we have seen the classification of data, we classified as the categorical data, numerical data. There is another way of classification is classifying it nominal data, ordinal data, interval data, ratio data. We will look at what is nominal data. Nominal scale classifies data into distinct categories in which no ranking is implied. The example of nominal data is gender, marital status. For example, gender, suppose you are conducting a questionnaire, suppose you have captured the gender male 0, female 1, this 0, 1 represents just the gender. You cannot do any arithmetic operations with the help of the 0 and 1. For example, you cannot find out the average. Software will give you some number, but there is no meaning for that. Similarly, marital status, whether it is married, unmarried, this is the example of nominal data. The next level of data is the ordinal scale. It classifies data into distinct categories in which the ranking is implied. Here the numbers are the ranked. For example, you may ask the customer to give you a ranking about their level of satisfaction, for example satisfied, neutral, unsatisfied. The faculty ranking, for example professor, associate professor, assistant professor, you see that there are rank is followed. For example 1 professor, 2 associate professor, 3 assistant professor. Student grades A, B, C, D, F, these are ranking because the numbers 1, 2, 3 represent the rank. The next level of data is interval scale. The interval scale is an ordered scale in which the difference between measurement is a meaningful quantity, but the measurement do not have true 0 point. The example of interval scale is, for example year, say now say this year is 2019, you can add and subtract something, you can add another 5 years 2024 or you can subtract another 9 years 2010, but you cannot multiply. If you multiply that number, for example 2019 and 2020, you will end up with a big number. There is no meaning for that, because there is no meaning for 0. The another example of interval scale is your Fahrenheit temperature. For example, in the Fahrenheit scale, the 0 represents freezing point, but it is not the absence of the heat, but absence of the temperature. But at the same time, in the Kelvin, for example minus 273, it is absence of heat. So, Kelvin will be the some other scale that you will see the next one. The ratio scale is the ordered scale, in which the difference between the measurement is a meaningful quantity and the measurement have the true 0 point, weight, age, salary, and the Kelvin temperature comes under ratio scale, because 0 Kelvin, that means the absence of the heat. So, in the ratio scale you can do all kind of arithmetic operation. For example, the nominal you cannot do any arithmetic operation, in ordinal you cannot do any arithmetic operation, in the interval you can add and subtract, but you cannot multiply. But in the ratio data you can do all kind of arithmetic operation, you can add, you can subtract, you can multiply, you can divide. You see the usage potential various level of data. For example, the usage potential of nominal data is not that much. The next one is ordinal, next one is interval, next one ratio. So, the ratio data is having the highest usage potential, the nominal data is having the least usage potential. This is more important. Why we have to know the different types of data? Because these types of data is helping to choose the right analytical tools for doing analysis. For example, if the data is the nominal data, you can do only non-parametric test. For example, the data is ordinal, here also you can do only non-parametric test. But if the data is interval, you can do parametric test. You see that interval you can do all of the above plus addition and subtraction. In the ratio you can do all of the above plus multiplication and division, and statistical methods you can go for parametric methods. So, the purpose of classifying the data into nominal, ordinal, interval, ratio is to choose the right analytical tools, whether it is a parametric or non-parametric. The other reason is sometime if we want to do a non-parametric analysis, that is used only for nominal data. Sometime the students the data may be nominal, but they may go for a parametric test. That should not be done. That is the purpose of knowing what kind of what is the nature of this data. So, in this class we have seen the introduction for data analytics, we have seen the importance of data analytics, we have seen the classification of data analytics, then we have seen what is the analytics and analyst, and we have seen different types of data. In the next class we will learn about what is Python, how to install the Python, and what kind of descriptive analysis we can do with the help of Python. So, the next class we will meet you with another lecture. Thank you very much.